Okay, so my job is not to show you every type of equation that can ever happen to you, right? My job is to give you a basic set of skills, and then you have to learn how to apply them in different situations. Now, we'll look at lots and lots of different applications. That's no big deal. But you must have a basic skill set in order to be able to make those applications work. Okay, can we agree on that? Yes. So that's what we're going to do today, is we're going to talk about solving equations. Now, again, I have to assume that you have some knowledge of solving equations, right? You've been in a math class before. But that I am not going to assume that means you know how to put it all together. That's just not who I am. So I'm going to go through some processes. I'm going to go through and show you step by step everything that could happen to you from A to B. And A to Z, I'm sorry. And then you can, of course, ignore what I say that you already know. Or, say, good, I know that. That's what you should do. You should reach around and pat yourself on the back and say, good, I know that part. I'm prepared for that. Yay. Not, oh my God, I'm not going to pay attention to what he's saying because I've already heard this before, right? I will get to new stuff. Trust me. But I need to make sure that you have the foundation. All right? Can you tell I've been getting some grief about that lately? Okay, here we go. So, first of all, let's talk about equations, what they are, and how to deal with them. Okay? We know that something is an equation because of one thing. It has an equal symbol. That's how you know that something is an equation. Now, that doesn't mean that everything that you ever see from now on is going to be set up as an equation to begin with. Most of the time, especially with the applications-based tests like the MCAT and NCEA, you have to create your own equation from the information they give you. So you also need to know that it has an equal symbol, or you can be given in words, and the one word that you're going to see more often than any other to mean an equation is the word is. Anytime you see the word is, just translate that as the equal symbol. Okay? So you'll see it in words as well. And again, we'll look at lots of different applications, so don't worry about that if you're worried about translating them. Okay? So, how do you know that something is an equation? Has an equal symbol. Or you see the word is. Good. Okay. Now, we're also going to talk about some inequalities. Those are those is greater than, is less than, that kind of thing. We're going to talk about those, but I'm going to tell you right now that they are exactly like equations except for one thing. So we'll just put that one thing in later when you see these inequalities, right? So I'm not going to include those in this little part. So first thing, right? When you're dealing with any equation, no matter what, either they gave you the equation or you built the equation. The first thing you want to do is you want to get rid of any brackets. Exactly. You're using the order of operations. And at first we're going to use it the right way, or the usual way, and then we're going to use it backwards to take things apart. But we need to get rid of any brackets first. Now you're going to see that there are occasions when you could use the brackets, or you let the brackets stay and do it later. It usually works with what are called literal equations. That's when you're trying to get a letter by itself. You have a whole bunch of letters and you're trying to get a letter by itself. Do you remember doing any of those at some point in your life? Okay, don't worry about it. We're going to continue. All right. So first, you're going to always look for brackets. Second thing you're going to do is you're going to clear any fractions. Now, believe it or not, you already know how to do that. Because the whole point behind equations is to think of the opposite operation. So keep that in your head the whole time. The opposite operation. Okay? All right. Now, and what operation does a fraction bar indicate? Division. And what's the opposite of divide? Multiply. So you can, yeah, as long as it's an equation. Now again, these are rules for equations. That doesn't mean that it applies all the time to every problem you ever see. So every time you see a fraction from now on, that does not mean you get to eliminate it. You can only eliminate it because it's an equation. Because an equation is kind of like a permission slip that tells you you can do anything you want as long as you do it equally. Okay? So you can do anything you want as long as you do it equally. Okay? So that means that I'm going to use multiplication to get rid of the division. But if I multiply one term by something, I have to do what?
Multiply the other terms.
Multiply all the other terms. Okay? So not just the ones with fractions. And again, we'll look at some examples so you'll see what that looks like. Okay? All right. So I'll just put in using multiplication just if you want to. You don't need to, but just think about doing the opposite. So what we're doing is taking things apart. Okay, guys, try to be a little quieter there, okay? All right, now, these two steps are common to all equations, and they have nothing to do with solving the equation. All you're doing is you're getting it cleaned up so that you get it ready to solve. Okay, the third thing is the same. You'll combine any like terms that are on the same side. And when I say on the same side, that means I'm going to look on the left-hand side of the equal symbol, see if there are any like terms. Then I'm going to look on the right-hand side. We're not talking about crossing the equal symbol, pulling anything from one side to the other. We're, again, right now, just cleaning it up. Okay? So if you want to put that on there, my voice is changing again. Remember, this is just cleaning it up, getting it ready to solve. There are times when you can take shortcuts, and you don't have to do exactly every one of those. But for the most of you, going through and cleaning and doing process step by step will be the way to go. Okay? All right. Anything in there look unusual? Have you cleared fractions from equations before? Yeah? So like if you had 1/4, that's 1 divided by 4. What's the opposite of divided by 4? Times what number specifically though? 4. Times 4. So you could multiply it by 1/4, and that would eliminate the fractions. We've multiplied fractions before. But if you do it to one term, you have to do it to how many of them? All of them. And again, we'll look at examples of that in action. It's a very simple process. Okay? All right. Next, you have to ask yourself, what kind of equation is left? Because there are lots of different types of equations. We're going to focus on 3. One of which, hopefully, you've had lots of exposure to because it's the basis for all other equations. But, again, we'll go through the process just in case. The others may be new to you or newer to you. Okay? But we'll go through them as well. It's no big deal. All right? Now, what kind of equation is left is determined by the exponent, also known as the degree. Okay? So if you don't see an exponent, what do you assume that exponent to be?
1.
A 1. So that means it's a first degree, or it's also called linear equation. And those are the foundation type of equations. That's the foundation of everything. That's your whole goal, is to get them all to become linear. Right? If it has the highest exponent of 2, that's a square or a quadrilateral. So those are when you get quadratic equations. Right? So we have to do something to unsquare it. Right? If you have an exponent of 3 or 4 or 5 or 6 or 7 or whatever, those are called exponential. And because they have higher exponents, right? And we need to undo that exponent. Okay? And that's the basic idea behind it, is you're just trying to undo it to try to turn that thing into a plain old X or a plain old Y. Okay? Your whole goal is to get X equals something, or Y equals something, or A equals something, depending on the letter that they give you. Okay? All right. So we're going to talk about the steps for solving linear equations, and then we'll go through a few of them just to kind of remind you, right? But we're not going to spend a whole lot of time here because year 10 was about linear equations. Year 11 is about quadratics and higher degree. Okay? So hopefully you've seen this before, but if you don't, you know me. Okay, so the first type of equations that we're going to look at, okay, so we'll just call it A. The first type we're going to look at are what are called linear equations. Now again, these are the basis for everything else, right? Your goal is to usually get these things to turn into linear equations by whatever method you can. But these are going to start out as linear. And we know they're linear because the highest exponent is a 1. Good. Which means that you're not going to see an exponent at all, right? Because if you don't have an exponent at all, you assume it to be a 1. Okay? Now, we have a goal and a method. If you keep the goal and the method in your mind, then you'll know what's going on. Here's your goal. Get the variable. What's the variable? The letter, X, Y, A, B, C, whatever. Completely by itself. So am I okay with 3x equals something? Nope. Am I okay with negative x equals something? Nope. Am I okay with x equals something? Yep, that's what I want. It has to be completely by itself. And it doesn't matter which side. I could have 4 equals x. My x is completely by itself. Or I could have x equal 4. They mean the same thing. Doesn't matter. Okay? The location of your x doesn't matter as long as it's completely by itself. All right. Here's our method. And I already touched on it briefly. After you get it cleaned up, right? You've already gotten rid of brackets, you've already gotten rid of fractions, and you've combined any like terms that are on the same side. Our method is to use the opposite operation. What we're going to be doing is we're going to be doing the order of operations backwards. Okay? Because we're taking things apart, not putting them together. Okay? All right, so our opposite operation. But of course, we still want to talk, I'm going to talk about some processes. So let's talk about that. So first, get all variable terms on one side. Oops. Now remember, all of the building blocks of algebra are terms, and a variable term is any term that has a letter in it. Yeah? Okay, so any term that has a letter in it needs to be on one side. Now, did I say on the right-hand side or the left-hand side? Nope. Doesn't make the slightest bit of difference to me. Normally, we move the smaller, if we're going to move one, we move the smaller one, because if you subtract a small number from a big number, you end up with a positive, right? So we try to keep that term positive by moving the smaller one. But if it becomes negative, who cares? We can fix it later. Right? But most of you are happier if things stay positive instead of having to work with signs. Yeah? Okay? Doesn't matter which side it is. You move it whichever way you want. And again, we'll look at plenty of examples. Okay? Second step. Get all number terms, because all you're going to have are variable terms and number terms in a quadratic. In a linear. Get all number terms on the other side. And this is where it goes kind of pear-shaped for a lot of students. I don't know which number to move. There are 2 of them, I don't know which one to move. Well, I know what to move. If my variables go left, my numbers go what? Right. If my variables go right, then my numbers go what? It's as simple as that. Okay? Don't worry about it. It's that simple. And keep it that simple. But you have to memorize the steps to make it that simple, right? You have to know what question to ask yourself. All right. Now to do this, what we're going to do is we're either going to add or subtract. Because if you remember, terms are separated each other by pluses and minuses. So to move an entire term, you do that by adding or subtracting. So if it's positive, you will do what? Subtract. If it's negative, you will add. So how would I move a negative 3? Add 3. But remember when I'm doing, I have to do it equally, so that means I add 3 to which side? Both sides. How would I move positive 2x? Subtract 2x from where? Both sides. Done. Okay? It's just that easy. Third and final step. Divide by the coefficient. Coefficient means the number in front, right, of the variable. Coefficient of the variable term. Okay? So whatever's in front of that x, that's what you'll divide by. Because remember, the coefficient is just a fancy word for multiplier. So it means you're connected with multiplication, and the opposite of multiply is divide. Okay? So what if I have 3x? That means 3 times x. So what's the opposite of multiply by 3? Divide by 3. Make sure you say the number part of it, right? Because that'll put it in your head. Not just divide, but what to divide by. That's the key to making it flow in your mind, is to make sure that you're asking yourself the entire thing, not just pieces of it. Have you ever gotten to a test and kind of remembered a little piece of it, but you don't remember the whole thing? Oh, yeah. That's because you're taking too many shortcuts when you're trying to learn this stuff, right? So it's not. So the opposite of multiply by 3x is what? Divide by 3. Well, just through 3, right? Okay, to multiply to divide. Yeah, I'm sorry, I said that wrong. Okay, so put that in your head. It's not just divide, it's divide by blank, whatever. Okay, now here's the one that's going to mess with you. Be careful. What if I have negative 2x? Negative 2x means negative 2, what? Times x. So what am I going to do? What's the opposite of multiply by negative 2? Divide by negative 2, right. We need to take that sign with it. Right? Remember, the sign and the coefficient are locked together. We need to take the sign with it. So if you're multiplying by a negative, you need to divide by a negative. And a lot of times you'll think add 2x because it's negative. It's not, because they're connected with multiplication. We have to use division. But we have to divide out the sign and the number, because we need that x to be completely by itself, right? That's it for linear equations. They're pretty darn easy. Two more types. Yeah, we're going to do a couple of examples right now just to make sure we're ready. Okay? So here we go for some examples. Say we have 3x equals, 2x minus 9. All right, we'll go ahead and put 5 plus 3x. Now, this one has some parts, but not all of them. Okay? Again, in the interest of time, I'm going to show you some. And there are also plenty of them to work. I'll show you where it is in your book. Okay? Now, first thing, how do I know this thing is an equation? There you go. Now, before I start working on it, I need to make sure I clean it up first. What do I look for first?
Brackets.
Well, brackets first, okay? Brackets first. Do I have any?
No.
Nope. Then I look for what next? Fractions. Do I have any? Nope. Then I need to see see if I have any like terms on the same side. Now again, remember, we're just looking on the same side. Be careful, on the same side. Are 5 and 3x like terms? No. Okay. Are 2x and negative 9 like terms? No. So there aren't any like terms that are on the same side. That's the key there. Okay. Don't be trying to move things yet. There are like terms, but they're not on the same side. All right. Next thing, I need to know what kind of equation this is. How do I know and what kind of equation this is? Yeah, you look at the exponents. The highest exponent is a 1, which means it is a linear or first degree. Good. So the whole goal is to simply get the x, what? Isolated. Well, completely by itself, right? And we're going to do that by using the opposite operation. Yeah. Guys, these should be right in front of you in your notes, right? All right? You can just read it right back to me. It's okay. Okay. Now, so the first step is I want to get all my variable terms on one side. Can anybody tell me how many variable terms I have up here? 4. Variable terms. 2. Remember, variable terms mean the ones that have variables in them. There are 2 of them. Now notice, when I circled this variable term, I circled its sign too, right? Okay? All right, so that sign is included. So that means if there are 2 of them, that means I've got to move one. Do I want to move 3 x's or 2 x's?
2 x's.
Yeah, we want to be lazy. Don't do the heavy lifting. Move the smaller one. And since it's a positive 2x, what's the opposite of add 2x?
Take away.
Take away 2x or subtract 2x. Well, if I subtract 2x from this side, I also have to what? Exactly. Whatever you do to one side, you do the same to the other. Now the 5 won't change. What's 3x's minus 2x's going to leave me with?
X.
Positive 1x or just plain old x. It's not wrong if you leave the 1 for now. It's perfectly fine. It makes no difference to me. All right? Now, equals. The 2x minus 2x, if you subtract something from itself, it makes a what?
1. 0.
Subtract from itself. 0, right? But I don't need 0 minus 9 because 0 minus 9 is just 0. So in other words, they subtract away. And that's the whole point. Everybody okay with that process? So what if I was moving a negative 5x? I would what? Add 5x, yeah. Or positive 5. Use positive 5x on both sides. Okay? Now, is my x on one side?
Yes.
Yes. Is it completely by itself?
No.
What's over there with it that I need to move? That positive 5. Positive 5, right? Say signs. I know I know this only 1 or 2 of you, but occasionally have trouble with signs. So say them every time. Positive 5. Well, how do I move a plus 5?
Negative 5.
So even though there's not an add in front, the opposite of positive 5 is subtract 5. From where?
Both sides.
Both sides. So over here, the 5s are going to subtract away. That's the whole point. The x stays. And what's negative 9 minus 5 going to make? So you keep the sign and add. So there you go. We got the variable terms on one side. We got our number terms on the other. Then we didn't have to divide this time because is the x completely by itself? Yeah, so we're done. I picked a bad example, but we'll look at another. So let's look at what happens. Let's say we had done all the other part of it, and we ended up with 3x equals 9. Is my x, okay, first of all, is my x term on one side?
Yeah.
Yes. Is it completely by itself? No. So what operation is connecting it to that negative 3? And the opposite, and multiply by negative 3. What's the opposite of multiply by negative 3? There you go. And whatever I do to one side, I have to do to the other. Remember, the key is you can do anything you want to an equation as long as you do it equally. Okay? Over here, the negative and the 3 are going to divide away. They really make a 1, but do I need to write a 1 in front of an x? No. And over here, positive divided by negative is a?
Negative.
9 divided by 3 is?
3.
Is my x by itself?
Yes.
Then I'm done.
Is that a new equation or is that?
No, he just said if this happened.
It's a linear equation, right? I just wrote a different one, right? So that you'd have another example. Because this one I accidentally picked numbers where there wasn't anything to divide by. Okay? Now, you're going to get a lot of practice with these. There's a ton of linear equations. All you have to do is look up linear equations in your book and find them. This is not today's lesson. This was today's revision. So here we go.
What? We have done it. Oh, it's revision from like when last year.
From your previous life.
Oh, so we had in our
Before you had Christmas break last time. Okay? Now, next we're going to talk about what are called quadratic equations.
What thing is it?
Good, that's an excellent thing. Now, again, quadratic equations are the workhorses for this course, which means that they're the ones you're going to see more than linear equations. But you have to have linear equations to solve quadratic equations. So that's why we talked about them. I know that something is quadratic because the highest exponent is a 2. Good. Okay? Now, you may not know that originally. You may not know it until after you clear some brackets and multiply it out or whatever. Okay? But as long as the highest exponent is a 2, no matter how that happened, then you're talking about a quadratic equation. There are a couple of different processes for solving a quadratic equation. You must use this one. So if you know the quadratic formula and you use it on the MCAT, you're going to get the entire thing wrong. You won't even get an achieved.
But what if we use what?
The quadratic formula. If you know that, don't even think about it. What have we been focusing on the last few weeks? But specifically factorizing. And that's the way you're going to solve your quadratics. Okay? That's why we spent so much time on it. All right. Come on, guys, hold on. Quadratic equations, the highest exponent is a 2. So our goal is to get rid of that exponent of 2, right? And there are lots of different processes for making that happen, but but we're going to focus on one of them because that's the one they want you to use. This is not me telling you you have to do it my way. This is the MCAT telling you that if you don't do it this way, you can't even get achieved. Okay? Now, to lighten the load a little bit, guys, as long as you get 3 U's or 3 achieves, you've got an achieved on the MCAT.
How many questions are there?
No, they're like 15, I think, or 12 or something, yeah. But
like
some of them are super easy. Some of them are super easy. Well, that means on question 1, you get an achieve. Question 2, you get an achieve. Question 3, you get an achieve. All right? And we're going to look at, and you're going to have... All right, quadratic equations. How do I know that an equation is... How do I know, first of all, that's an equation?
Equal sign.
Equal symbol. Good. So the first thing I need to get rid of are what? Brackets. Then what? Fractions. Then I need to combine like terms that are where?
On the same side.
On the same side. Then and only then can I ask myself what kind of equation it is. Right? And if I see an exponent of 2, that the highest exponent is a 2, that means it's what kind?
A quadratic.
Quadratic. And we're going to learn how to solve them by factorizing. Now, are there other process methods? Yes. But they are going to specifically ask you to solve it by factoring. And remember, MCAT this is the NCA version, so I'm sure they've changed it to factorize. But if you see the word factor, that means the same thing, right? You've been around me enough to know that. Okay, let's talk about the steps. First step. Set the equation equal to 0. Factorizing is also known as the zero factor property. And the reason for that is because your first step is to set it equal to what?
0.
Your second step, what do you think? Is to factor it. So, again, mathematicians aren't very clever when they name things. They name it by what do you have to do first and what you have to do second, whatever. So, zero factor property. Set it equal to 0, then factor it. So, again, sorry. I just find that amusing. Well, hold on a minute. So, set it equal to 0. Now, in the other one, in linear equations, I wanted all my x terms on one side and my numbers where?
On the other side.
This time, I want every term on one side. So, all terms on one side. So that means that after the equal symbol, all I'm going to have, if I subtract everything away, the only thing I'm going to have on the other side is a 0. Right? Okay? And all my x squareds, my x's, and my number terms are all going to be on one side. And then on the other side, all that's left is a 0. And we're going to look at lots of these. Okay? Now, second step of the zero factor property might be to what? Factorize, yeah. Factor completely. Notice I underline the word completely. Remember, we don't ever say factor. We always say, guys, factor completely because you have to it makes sure that you go through every process. And what is the one thing that's the easiest to do that I told you everybody's going to forget to do? G, C, what? F. All right? Now, here we go. Now that I'm back on. So, GCF means anything that'll divide how? Evenly into what? Every term. There you go. All the terms. Good job. Okay? So, it can be a number, it can be a letter, it can be an entire bracket. Usually it's a number or a letter. Okay? If that first term is negative, then your GCF should also be negative. Right? Remember that? Okay? Good. Hopefully factoring is not new. Then you count the number of terms. If you have 3 terms, that's a trinomial, and we use that AC method to factor it. Right? Remember that?
Yeah.
Okay, that was the whole point of all of that, was to do this. Then, step 3. Come on, guys. Focus with me. Set each factor equal to 0. So we've broken it into two factors, right? So we'll have brackets, right? We're going to set each one equal to 0. But there's no math here. Like originally, we might have had to set it equal to 0 by moving a 2x or subtracting a 5 or whatever. But in this step, there's no math. All you're going to do is take each bracket and put equals 0 at the end. Okay? Because what you have is two things multiplied together to make 0. And in order to do that, they have to equal 0. So all you're doing, and you may not care about the y, but just set them equal to 0. And when you do that, you don't even need the brackets anymore. Because they're not stuck together and they're not multiplied together anymore. Step 4. Solve the resulting linear equations. Because what happens is, once you factorize them, they're no longer x squareds. They're just x's and x's, which means they're linear, which you saw means solve them by doing the what? Opposite operation. There you go. And usually it's pretty clear cut what to do. The factoring, the solving is released. Okay. We expect two solutions. And you may or may not have heard this. I'm sure you've heard it before in your past, but you may have forgotten it. Whatever the highest exponent is, that tells you how many solutions you can expect. Now, we say expect because sometimes you can get one solution for something that's like x to the 5th because it's the same number over and over and over again. And you don't write it down 5 times. So if I get 3 and positive 3 and positive 3, I'm just going to write down what? Positive 3 one time. Yes, ma'am.
If you get like two possible x's in an equation, for example, like a rectangle.
Okay. Yes.
Would you get rid of one? Let's say if you have a negative one.
Exactly. So you're talking about we're talking about just solving a basic equation that's not an application now. But say you get one of them and it's the length of a rectangle and you get positive 5 and negative 7. Well, we have to reject the negative 7 because length can never be what? Negative. Same thing with time. Can time ever be negative? Okay. The number of people in a classroom can't be negative. So there are times exactly when you're working with applications, which is what most of these problems are going to be like. If you get a negative, most of the time you have to reject it, and we'll talk about that. And if you do, guys, focus. And if you do start off with an application, in other words, it's written in words and not as a thing, you have to write the answer in a sentence. So, the number of people in the theater was 5. We had to reject negative 7 because the number of people can't be negative. That's the difference between achieved in merit and excellence, right? So you've got to make sure that you describe it. So you can describe any answers. Our two answers, even if you just solve an equation, you can say our two answers are negative 5 and positive 7 or whatever. Okay?
Does reject mean like it just goes away? Or
Yes, because it can't exist. I mean, you got two answers, but you had to reject one of them because, okay, yeah. Like today, you are going to ride the bus or go to the moon.
Ride the bus.
Right, because go to the moon is not going to happen. So you throw it away. Have you ever heard something that wasn't true before? I know none of you have, right? Okay? Has anybody ever told you something that's not true? What do you do with that? And what do you do with that information? You ignore it, throw it away, right? And then use it back at them later. Yeah. Okay? So, yeah, you hear stuff that's not going to work all the time. So here we go. Let's review these. First, how do I know that something is an equation? Equal symbol. So first thing is to clean it up by looking for what? Brackets. Okay. What do I look for next? Fractions. Then I combine any like terms that are where? On the same side. Excellent. Then I need to know what kind of equation it is by looking at the what? Highest exponent. Good. If the highest exponent is a 2, then it is called a what? Quadratic, because 2 is also known as square, which is a kind of quadrilateral. All of these things are named after geometry because the Greeks used to solve them using geometry instead of algebra. So that's where the name, just in case. All right? It's a pain. All right. So, first step in solving any quadratic equation is to what? Set the equation equal to 0. They're right in front of you, and they're on the board. Okay, so all you have to do here, guys, is read. Okay. All right, set the equation equal to 0. That means get all of the terms, not just some of the terms, but how many of them?
All of them on the same
On one side. Does it matter which side?
No.
No. It could be 0 equals all this crap or something equals 0. All right. The bad part is I record all this stuff too. All right, now, next.
Factor complete.
Then factor completely, making sure the first thing you look for is a what? How dead are you if you don't do the GCF?
Dead. You can't
Dead.
get it.
So dead.
Can't get an achieved. It's not going to be pretty. Okay? All right, here we go. After you have it factored completely, then you're going to set each factor equal to
0.
0. Do you do any math of that?
No.
Nope. I'm just going to put an equal symbol and a what?
0.
A 0. And so when I do that, I'm going to break it into two equations, so I don't even need the brackets anymore. Because I only needed the brackets when they were multiplied together. But now I've separated them and turned them into two different equations. And then I'm just going to solve the resulting what? Linear equations by simply doing the opposite, right? The opposite operation. And how many solutions do I expect?
2.
2. Am I always going to get 2?
No.
No, if I get one that repeats like 3 and 3, then I just write it down one time. Yes, ma'am.
How does it become a linear equation just by adding zeros?
Because when you take the x squared and factor it, remember x squared became some x times another x when we factorized it. So that exponent of 2 goes away. We're going to look at some examples. Okay? All right, here we go. Now, here we go. So say we have 2x squared minus 5x minus 12 equals 0. First of all, how do I know this thing is an equation? Equal symbol or equal sign if you want. It's fine. Okay? All right. Now, in brackets?
Nope.
Fractions?
Nope.
Like terms on the same side? No. That's an x squared. That's an x. They are not like terms unless they have the same base and what? Exponent. So x squareds can be combined with other what? X squareds. X's can only be combined with other what? And numbers can only be combined with other what? Numbers. There we go. Okay? Yes, so. Hold on, we're not there yet, but yes. Okay, now, so I know it's an equation. I can't clean it up. There's nothing to bother with that. So the next thing I need to know is what kind of equation it is. How do I know what kind of equation this is?
The exponent.
Exponent of what?
2.
Which is a square, which means this is a quadratic. To solve this quadratic, we're going to be told you solve it by using the zero factor property or by factorizing. It means the same thing. So the first thing I need to do is set it equal to what?
0.
What do you notice?
It's already set.
It's already been done for you. Second thing I need to do is what?
All terms are what?
Completely. Factor completely. First thing I look for when I'm factoring anything is Is there anything common to 2, 5, and 12? No. Is there an X in all of them?
No.
So is there a GCF? No. Okay. How many terms?
3.
So that makes it a trinomial. Hannah's been busting at the gut. Okay. So it's a trinomial. So that means using the AC method. So A is what?
2.
B is what?
12.
B is what?
5.
Negative 5. What's C?
Negative 12.
Negative 12. So I'm going to take my A, which is 2, times my C, which is negative 12. And look at that. I even use an X for you instead of a dot. I hate it. I can't do it. Sorry. All right. Which gives you negative 24, an AC of negative 24.
Wait,
Good.
why times? Oh, because the 2.
A times C. AC method. A times C. Multiply by A times C. I need to start listing factors of AC that will combine to make what?
24.
Negative 5.
Negative 5. They have to multiply to make 24, but they have to combine to make negative 25. 1 goes into it 24 times. If I add them, I get 25. Is that what I want? Nope. If I subtract them, I get 23. Is that what I want? Nope. So who cares? Yeah, we've done this very problem. 2 goes into it what? 12 times. If you add them, you get 14. Is that what I want? If you subtract them, you get 10. Is that what I want? Nope. 3 goes into it what? 8 times. If I add them, I get 11. Is that what I want? If I subtract them, I get 5. Is that what I want? Yes. But I want that 5 to be what?
Negative.
Which means that the bigger one has to be the negative. Because negative 8 plus 3 makes negative 5. If you did negative 3 plus 8, you'd get positive 5. Does a positive times a negative still make the negative that I started with?
Yes.
Remember, we have to check those signs, right? Okay? So that works. So I'm going to bring down my 2x squared. Instead of negative 5x, what am I going to put?
Plus 3.
Plus 3 what? X. Then what?
And then negative 8.
Negative 8 what?
X.
X. Good. And then minus 12 comes down, and it still equals 0. So don't just keep bringing down that equals 0. It's important, but you're never going to use it. You're not going to work with it. Now we'll break them in half. What's common to 2x squared and 3x?
X.
X. 1x or x, that's fine. 2x squared divided on an x, what's left?
2x.
2x, good. Positive 3x, divide out the x, what's left?
3.
Sign, please.
Positive
Positive 3. What's important about that sign behind the split?
Negative.
We always bring it down. It always just comes straight down unchanged. What's common to 8x and 12? 4. Be careful. It's got to be the greatest common factor. Good job. Negative 8x divided by negative 4 is what? 2x. Negative 12 divided by negative 4 is? Positive what? 3. Excellent. Do the brackets match?
Yeah.
Yes, and they have to. So I'm going to get 2x plus 3 times what? X minus 4, and it still equals what? 0. Okay? You don't need the equal 0 when you're factorizing, but once you're finished, remember it's still an equation. Nope. What's the next step to say to do? Now the next step is to set each one equal to 0. So it's 2x plus 3 equals 0, and x minus 4 equals 0. Which means I no longer have one quadratic equation, but two, what are they called? Linear. And you can tell they're linear because you don't see any exponents. Yeah, because you don't need the brackets anymore. Once you separate them into two equations, that's what I was saying. Once you set it equal to 0 and you don't need the brackets anymore, because the brackets were only because they were multiplied together. Are they multiplied together anymore? So you don't need the brackets. There you go. Good questions. So to solve the first one, I want to get the positive 3 away from the 2x. But how do I move a plus 3? Minus 3 from where? Good job. So that leaves me 2x equals negative 3. Then what?
Separate 2 from it.
It's 2 times x. The opposite of multiply by 2 is divide by 2.
I can't take it.
Okay, it's all right. Yes, you can.
Yeah, what is this?
Which gives you x equals what's? Negative 3 over 2. I'm sorry. I know I'm going fast, but we're about to run out of time. All right?
The next one.
This is linear equations. This is what you did all year last year.
I feel like we didn't.
You think all you didn't? Okay. Linear equation. We solved a linear equation, right? Let's do it again. Come on, guys. Hold on. Let's focus here. Don't tell me you can't do something. Focus on how you can. All right? It's an equal symbol. That makes it an equation. There's no exponent, so it's linear. I want to get all my x's on one side. How many x terms do I have? X terms only have 1. So is it moving? No. How many number terms do I have? 2. So that means one of them needs to move. My goal is to get this by itself. Guys, come on. So how do I get that? So I need to move that, add 3. What's the opposite of add 3?
Minus.
Then whatever I do to one side, I do exactly the same thing to the other. Over here, the 3's will subtract away, leaving me just 2x. What's 0 minus 3?
Minus 3.
There you go. Is my x by itself? How is that 2 connected to the x?
Multiple.
And what's the opposite of multiply by 2? Divide by 2. There you go. But if I divide one side by 2, then what? There you go. 2 divided by 2 is going to make 1x. But do I want to write 1x? No. Just write x. Got it? Over here, negative divided by positive makes a negative. And 3 divided by 2, will that divide evenly? No. So I just get 3 over 2.
Oh, wow, that went really fast.
Okay? Now, this is just the other one. X minus 4. The only thing I need to do to get the x by itself is move the 4. How do I move a minus 4?
On one side.
We add 4, right? Which gives us x equals 4. So my two answers are negative 3 over 2 and positive 4. All right. Quadratic equations. Do some of those problems. They're on page, let's see, page 50 and 51. Page 50 and 51. Make sure you do them. All right?
Have we got any results back?